Yes, number theory 3.30. Mr. Nam baked 252 cookies, Mrs. Clancy baked 105 cookies, and Mr. Palvis baked 168 cookies. Each baker packaged them with the same number of cookies in each package. What is the greatest number of cookies that could be in each package? So if you do the greatest number of cookies in each package would be the greatest common divisor of 252, 105, and 168. So if you do prime factorization, 252 and 105 and 168. First you can do 3, and this would be 84, 35, and 56. And then you can do 7, so it would be 12, 5, and 8. So the greatest common divisor, since you can't do, can't do anymore. So greatest common divisor is 3 times 7, which is 21. So the greatest number of cookies that could be in each package is 21. AOPS number theory 3.31. We can construct 5 and 10 as differences of multiples of 25 and 15. In this, for example, this. In this way, generate the next 8 smallest multiples of 5. So then, after this, it would be 0 times 25 plus 1 times 15 is equal to 15. And then 2 times 25 minus 2 times 15 is equal to 20. And 1 times 25 plus 0 times 15 is equal to 25. 0 times 25 plus 2 times 15 is equal to 30. 2 times 25 minus 1 times 15 is equal to 35. 1 times 25 plus 1 times 15 is equal to 40. 0 times 25 plus 3 times 15 is equal to 45. And 2 times 25 plus 0 times 15 is equal to 50. AOPS number theory 3.32. There are 25 primes less than 100. Is their sum even or odd? We know that every prime number is odd except for 2, which is even, and every other is odd. So since there are 25 primes less than 100, that means there's 1 even and 25 minus 1, which is 24, odd. So when odd plus odd is equal to even, and if you add an even number of odds, it will also always be even. So 24 odd, the sum of all the odds is even, and the sum of 1 even is obviously even. And even plus even is still even. So over here we have 2 even. So the sum is still even. So the sum is even. AOPS number theory 3.33. How many positive integers less than 101 are multiples of either 5 or 7, but not both at once? So first, there are 20 20 positive integers that are multiples of 5 under 101, and there are 14 positive integer multiples of 7 under 101, but 35 and 70 are multiples of both 5 or 7, so that's 2. So then that means that there are 18 multiples of 5 that are not multiples of 7, and there are 12 multiples of 7 that are not multiples of 5. So then the total would be 18 plus 12, which is 30.